Welcome to Mindful Journey, a channel that embarks on insightful quests to unravel the mysteries of science and the universe. We're here to ignite your curiosity and feed your thirst for knowledge, diving deep into scientific phenomena that shape our world and beyond. Your engagement fuels us, so remember to like, share, subscribe, and engage in the comments section. In today's journey, we dive into a fascinating topic: the geomagnetic reversal. Buckle up for a thrilling ride into the heart of our planet's magnetic field. Imagine a compass, a tool that has guided explorers for centuries. Now imagine if suddenly the needle started pointing south instead of north. This is not the premise of a science fiction tale, but a natural geological phenomenon known as geomagnetic reversal. In the simplest terms, it's when the Earth, like a giant magnet, decides to flip its poles. The magnetic north becomes south and vice versa. But how does this happen? Our planet's magnetic field is generated by the churning of molten iron within its outer core. This process, akin to a natural dynamo, creates electric currents that result in a magnetic field surrounding the Earth. Imagine it like an apple, with the core generating a magnetic field that extends outwards, wrapping the entire apple in an invisible magnetic blanket. Now, due to the dynamic nature of the Earth's core, this magnetic field is not static. It's constantly on the move, shifting, and sometimes it flips entirely. When this happens, our trusty compass needle, always pointing north, would start pointing south instead. Such reversals have occurred multiple times in Earth's history, with the last one happening nearly 800,000 years ago. This event, known as the Brunhes-Matuyama reversal, saw the magnetic North Pole shift to the south. But don't worry, it's not something that happens overnight. These reversals take thousands to tens of thousands of years to complete. It's important to remember that while this might seem alarming, geomagnetic reversals are a natural part of Earth's life cycle. They don't cause mass extinctions or catastrophic events. In fact, life has continued to thrive through multiple reversals. So, geomagnetic reversal is not about the Earth going haywire, but rather it's part of the planet's natural rhythm, its geological heartbeat, if you will. So, in essence, geomagnetic reversal is like Earth deciding to change its magnetic hairstyle, flipping its magnetic field in the process. It's a fascinating testament to the dynamism of our living planet, constantly changing, constantly evolving. The question that arises is, are we due for another geomagnetic reversal? Let's delve into this by first looking at what the geological records tell us. These records, etched into the crust of our planet, highlight a fascinating pattern. Geomagnetic reversals, it turns out, aren't as punctual as one might think. Instead, they occur at irregular intervals, averaging out to about every 200,000 to 300,000 years. Now, here's where things get interesting. The last geomagnetic reversal, an event termed as the Brunhes-Matuyama reversal, took place approximately 780,000 years ago. Yes, you heard that right. We're living in an era that's seen the compass needle pointing north for almost twice the average period between reversals. This fact has led some scientists to speculate that we might be overdue for another reversal. But wait, let's not get ahead of ourselves. It's important to remember that these averages are just that. Averages. They're derived from millions of years of Earth's history, and they don't predict exact timings. The intervals between reversals have varied widely in the past. There have been periods when the magnetic field didn't flip for up to 1 million years, and other times when it flipped several times within a span of a few million years. So are we due for a geomagnetic reversal? The honest answer is, we simply don't know. The Earth doesn't operate on a strict timetable. The magnetic field could flip tomorrow, or it might not happen for another few 100,000 years. The key takeaway here is that, while the geological records give us a fascinating glimpse into our planet's magnetic past, they don't provide a crystal ball into its future. Predicting the when of a geomagnetic reversal with any degree of certainty remains a tantalizingly elusive goal for science. But before you start worrying about your compass going haywire, let's understand what a geomagnetic reversal might mean for us. A world where compasses point south might sound unsettling, but what does a geomagnetic reversal mean for life on Earth? It's a question that's intrigued scientists and laymen alike for centuries. Firstly, let's talk about our everyday lives. In a world where our compasses point south instead of north, navigation could get a bit tricky. Imagine setting out for a hike with your trusty compass, only to find it leading you in the exact opposite direction. A bit disconcerting, wouldn't you say? But it's not just your weekend camping trip that could be affected. Our entire global navigation system, including the GPS technology that we rely on for everything from driving to drone delivery, could go haywire. But wait, there's more. The effects of a geomagnetic reversal could extend far beyond our earthly confines. Our satellites, those silent sentinels orbiting the Earth, could experience significant disruption. You see, our planet's magnetic field protects these satellites from solar radiation. During a reversal, this shield could weaken, leaving our satellites vulnerable to damage. This could impact everything from weather forecasting to satellite TV and internet connections. So, it sounds pretty dire, right? Well, not necessarily. While these scenarios might seem alarming, it's important to remember that a geomagnetic reversal is not an instant event. It's a slow, gradual process that takes thousands of years to unfold. This gives us plenty of time to adapt and adjust our technology to a new magnetic norm. Furthermore, there's no concrete evidence that a geomagnetic reversal would have a catastrophic impact on life on Earth. In fact, these reversals have happened several times in our planet's history, and life, as we know it, has continued to thrive. However, it's always wise to be prepared. The more we understand about geomagnetic reversals, the better equipped we'll be to handle any potential challenges they may pose. However, rest assured, a geomagnetic reversal won't happen overnight. It's a slow process that takes thousands of years to complete. And during that time, we'll continue our journey, navigating the ever-changing landscape of our incredible planet. So, as we stand on the brink of potential magnetic mayhem, are we ready for a geomagnetic reversal? We've journeyed through the intriguing realm of geomagnetic reversals, diving deep into the mysteries of our Earth's magnetic field. We've learned that these reversals, while seemingly ominous, are a part of Earth's natural cycle and have occurred numerous times in our planet's long history. We delved into the question of whether we're due for another reversal and discovered that, while the signs might be there, these processes take place over thousands, sometimes even millions, of years. So even though we might be in the early stages of a reversal, it's unlikely any of us will see the flip in our lifetime. We've also explored the potential impacts of such a reversal on our modern world. While there could be some disturbances to our technology, the gradual nature of the process allows us ample time to prepare and adapt. The potential for catastrophe, while a tantalizing thought, is far from the reality. In essence, while the concept of a geomagnetic reversal can seem daunting, it's a natural process that we as a species have survived before and will likely survive again. Instead of fear, let it inspire a sense of wonder and curiosity about the incredible world we inhabit. Thank you for joining us on this journey. Don't forget to like, share, and subscribe to Mindfull Journey for more exciting explorations into the world of science. Until our next journey, keep your curiosity alive and stay mindful.